Welcome to a lesson with Dr. Powell. Let's take a look at some values of functions, output of functions that deal with the 0 plus and 0 minus. For instance, what is the ln of 0 plus? Okay, what in the world does this mean? So this means that we're heading to 0 from the right through positive values. This is like, kind of like that a limiting idea. So if we're looking at the ln of that, this is really a limit statement. You could think of it, what is the limit as x approaches 0 from the right side of ln of x? It's nothing more. This is the exact same thing as all of this. Okay? Just another way of writing it. It's just notation, if you will. But you can kind of think about, but this is kind of neat right here, because it looks like we're plugging something in. Because we're plugging something in pretending that the ln function is right continuous if we have our extended number lines on the x and y axis, with infinity as actually being as points. I have another video that describes that idea more. But in that sense, if we're thinking of it that way, the ln function actually looks something like this. And it crosses and it goes down to that point. Okay, so the ln function looks something like this, crossing at 1. So now, so we're going to be looking at so we want this function to be right continuous at x equals 0. So how do we have to fill in points? We fill in this point to make it right continuous at x equals 0. In fact, it's not even defined over here, so we're good. But it's right continuous at, let's see, so at this point coming down there. So if we fill in, so it actually is a plug-in if we're thinking about plugging 0 into a right continuous version at 0 of the natural log function. And then it is like a plug-in. So you literally can think about that. Then if you did that, you'd actually get the ln of 0 plus is equal to negative infinity. This idea extends to other things, such as, what about the inverse tangent? Let's see. Well, I mean, yeah, I guess you can think of it that way. Inverse tangent's a little bit different because you're looking at something that goes like this with some asymptotes, so it's kind of on its side. But, let's see. Right, so you can kind of think about it that way. So you kind of get inverse tangent, but you could plug in. But the nice thing is you have on the number line, if you plugged in infinity, you can actually plug in infinity this way into it, because you have everything on its side if you kind of filled in. So thinking about infinity, thinking about filling in at infinity at a point. So you could actually fill in the graph of tangent inverse at infinity if you kind of squashed your number line, so there'd be a point at infinity, so it actually comes up right to there. So you can plug it in, and this asymptote line happens at y equals pi halves. So you could actually get pi halves. So that's good for inverse tangent. But what if we reverse this process? What if we did tangent of pi halves from the left side? Okay, so wait a minute. Just like we have like 0 plus, 0 minus, we could also plug in things like pi halves minus to something. What does that mean? Well, in the graph of tangent, as the x values approach pi halves from the left, looks like we're going up to infinity. And if you allowed this continuous plug-in whole thing, you could actually think of it as a plug-in. So pi halves into a into a left continuous version of a left continuous version at pi halves of the tangent function, with the infinity kind of happening. And then it would be a plug-in. You can actually plug in pi halves minus, and then you would end up being simply just infinity. In contrast, the tangent of pi halves plus from the right side, so coming like this, is actually going to be notice it's going to go down this way. It's actually going to be equal to negative infinity. So a couple different options. So ln, we have that, tangent, inverse tangent, and you could find other types of examples to play around with. Hopefully that gives you a little description of how we can use these symbols when we're plugging in to things and be dealing with infinities and or zeros. Thanks for watching.